Hi there folks, just wanted to go over some of the answers and just give you some extra instructions on how to do this first assignment. So question number 1 says use the diagram below to answer the questions. So here's my diagram. I've included a number line. When I'm looking at the number line, the 0 is the origin. Anything that is a positive value is to the right of the number line. Right is positive, and anything on the left is going to be a negative value. So my first question is, the bear's position is x equals, and this is where he is right here, so x equals 3, meaning that he is 3 meters to the right of the origin. The rhino's position, right here, is x equals 13, meaning he is 13 meters to the right of the origin. The monkey's position is right here. He is -1 because he is left, so meaning he is 1 meter to the left of the origin. Question number 2 deals with vertical number lines. They work very similarly to your horizontal number line. Our positive numbers are above, and our negative numbers are below the origin, whatever we decide that to be. This is our origin right here. For question number 1, it says, why is the origin located where it is? Well, this is sea level, which means that that is our point between where the air is above, that's our positive value, and the sea, which is below, those are our negative values. The first question here, second question, the seagull is located, well, here's our seagull. I'm going to draw a little line. Our seagull is located at 4 meters above the origin, meaning that our position is +4. What animal has a position of -6? So -6, that's below sea level. It's this right here, which I'm going to say is a puffer fish. The eagle has a position of +7, meaning it's located 7 meters above the origin. What animal is located 3 meters below the origin? It is a clownfish, that's Nemo. And its position is -3, negative because it's below the origin. The sea otter's position, well, this one's a little trickier because it looks like it takes up a bit of space. So its top would be at +1. Bottom would be at -1. So there's a couple of possible answers here, anywhere from +1 to -1. I'm just choosing to go with it at the middle here. So it is 0, and it's located 0 meters, and it is at the origin. But depending on how you interpreted that picture, it kind of depends. What is the shark's position, and what does it mean? Well, this shark is located between -8 to -10. And this means that it is below the sea level, or the origin. Many of our questions have a negative position, means to the left. What does a negative position mean in this question? Well, this means it's in the water or below sea level. The second or third question is dealing with a squirrel that's running around. This time it's not linear. According to this number line, my squirrel's at different positions, and you can see that my numbers here are all changing. So time equals 3 seconds, time equals 0 seconds, time equals 3 seconds. So it's changing around, meaning this is running back and forth. My tree is still the origin at 0. This is the left of the tree. This is the right of the tree. Okay. So now I'm just going to look at the values that are given in the question to figure out what my answers are going to be. So at 0 seconds, right here, this is where I'm starting. The squirrel starts 6 meters to the left of the tree. At 3 seconds, so I need to go find 3 seconds here. 3 seconds is this one. My squirrel's position is -10. So So you'll notice that this one is asking you how many meters to the left. This one is giving you x equals -10. So I need to have my negative here to indicate that it is left of the origin, and it is 10 meters to the left of the origin. At 5 seconds, the squirrel's position is at -2. At 8 seconds, the squirrel's position is x equals +6, and it is 6 meters to the right of the origin or the tree. At 10 seconds, the squirrel's position is at 3 meters to the right of the origin. What is located at the origin? A tree. So one of the things to note here is that our positions are vectors. What that means is that we have a positive or a negative in front of the values. Positives mean that we are to the right or above. Our negatives mean that we are to the left or below the origin. The squirrel's motion is showed on the position time graph before. So here's my position time graph. Time is on my x-axis, moving forward at a steady pace, and my position is located on the y-axis. So I have the positive values, which mean that I am the right. The 0 is the tree, and anything negative is to the left of the tree. So there are a couple values in here that are incorrect. So we're gonna go through and just double check all these points. When time is equal to 0 up here, we said that the squirrel starts at 6 meters to the left. So this dot right here is in the wrong spot. So we're actually gonna go and mark it down here. So at 0 seconds, this is where my squirrel should have started. It was 6 positions to the left of the tree at a -6. The next one is at 3 seconds. My graph is telling me that at 3 seconds, the squirrel was 10 meters to the left, and that checks out with what's given to me in the question. So this one is correct. At 5 seconds, the squirrel is located at -2 meters or 2 meters to the left of the tree. This one is correct. This next one tells me that my squirrel was at this position at 6 seconds, but that was not given to me in the question, so this one needs to be moved. The next time that was given was 8 seconds, where my squirrel was 6 meters to the right, so I need to plot that point. So at 8 seconds, my squirrel will be at 6 meters to the right there. My last value that was given was at 10 seconds, the squirrel was 3 meters to the right. So that one should actually be located right here. Now I'm going to just redraw the lines on my graph using a ruler. So if you've had math last year, you might remember that we spoke a lot about lines of best fit. When we're doing position time graphs, we actually are usually doing a dot to dot. We're just mapping where different objects were at different points in time. So a dot to dot graph like this is appropriate. Okay. The next question, question 4, is a similar style of question. This time you're going to be using the information given to you in the question to answer the data table and fill in a chart as well as a number line. So I'm just going to go ahead and fill in this T-chart first. So time and position. Our time is given as 0 seconds, 3 meters to the left. We know that left is a negative value, so I'm going to put a -3. At 2 seconds, the squirrel is 7 meters to the right. This right is a positive value, so I will write +7. At 4 seconds, the squirrel is at the pole. This is the origin, and I know that because it gave me that information in the original question, so that would be our 0. At 7 seconds, it's to the right, so this is again a +2. And at 10 seconds, the squirrel is 5 meters to the left, which is a negative value, so that is a -5. I'm going to use this information in this data table to plot that on this number line right down here. So at 0 seconds, my position was -3. So this is my x values. This is my time. So at 0 seconds, the position should have been -3. Oh, this is actually labeled incorrectly. This is a Y, this position. So, -3, here we go. I'm gonna write at the top time equals 0 seconds. Then at my position that is +7 right here, I'm gonna write time equals 2 seconds. At my next one, 0, time equals 4 seconds. At the next one, time equals 7 seconds. And then time equals 5 seconds. I'm going to use these values in this data table in order to plot the points on my graph. So when time was equal to 0, the squirrel's position was -3, right here. When time equals 2, the position was 7. When time equals 4, the position was 0. When time equals 7, my position was +2. When time was 10 seconds, my position is -5. And again, I'm just going to connect these with a ruler. The next page was page 5. You should be able to handle that one on your own. Question 5. Number 6 here. It says get the story graph match cards. This is a file that's located, or it was attached, or it's located in the file section. We are going to be giving you an assignment with this. So you're gonna wanna figure those out, and it's matching a story to a graph as well as a data table. Okay, so you'll have to match those together. The last one that I want to talk about today is question 7. So it says consider the time graph below. It shows the motion of 3 objects, all moving along the same coordinate system at the same time. So according to this, I've got time, I've got my position. All of these are to the right of the origin because they're all positive or above. Object A, right here. Object B, and object C. So you can see object C has quite a different slope there. So which objects are moving in a negative direction? So negative direction means that I am moving to the left. So traveling to the left, and this is object C. The reason why I can tell is at 0 seconds I started at 100 meters. At 5 seconds it's now closer to the origin at 80. At 10 seconds it's at 60 meters from the origin, and it's moving closer and closer to the origin. So if origin is here and 100 meters is here, it's actually moving in this direction and it's going left. That's origin. Which object is moving the fastest? Well, this is object B. We'll notice that as time is going up, it is displacing, or it's moving at a quicker pace. So in 5 seconds here, it's moved 10 meters. In this, it's moved another 10 meters. So it's moving 10 meters every 5 seconds. Object A is moving quite a bit slower. So in this 5 seconds, it's actually only gone, looks like about 5 meters. Which object is moving the slowest? Object A. At what times are object A and B in the same position? Well, that's going to be right here where they're crossing. So that's going to be at 10 seconds. And on a number line below, mark where object A and B are at the 15-second mark. So here's 15 seconds. Object A, or object C, was at 40 seconds. And it's moving to the left. Object B was at 70 meters. And it's moving to the right. And object A is at 90 meters, and it is moving to the right as well. Which object is moving the fastest? I just realized I messed that up. That is object C. It's got a very steep slope. But between A and B, B would have been moving fastest. Anyway, there you go. All right, so you should be able to finish the rest of the questions in the booklet. Please feel free to email or chat with either Mr. McCoy or myself if you have any questions. Thank you very much. Have a great day.